Hello all! Welcome back to the Knowledge Tower, where we investigate the science behind the Bionicle legend. When it comes to iconic sights from Bionicle, few images could come closer to capturing the awe and mystery of the series than that of the Red Star. The enigmatic object hung over the skies of the endless ocean, acting as a prophetic harbinger in the astrology of the Matoran of Matanui. It was later revealed that it was not a true star, but it was in fact a space station housing the Castora species and a rocket booster for the Great Spirit robot. The star also had a wide range of other abilities, from the creation of new Toa via bolts of lightning to the resurrection of dead Matoran universe inhabitants. While these reveals were definitely cool additions to the lore, for me, and I think for most Bionicle fans, the view of the star through the Great Telescope on Tawahi Beach is what was most memorable about it. Replaying through the Matanui Online game and revisiting that iconic sight got me thinking, if I were a Matoran on Matanui looking up at the night sky, just what sort of sight would I be greeted with? Would the red star look like just another star in the sky, albeit with a very distinct coloration, or would it be a more prominent object, like the moon is here on Earth? We just don't get that sense of scale when viewing the star from our computer screens. In this video, we are going to dive deep into the evidence at hand to find out how big the red star would really look in the sky. When we are wanting to describe the size of an object in the sky here on Earth, we use angular measurements, splitting the sky into degrees like with a circle. The view from one horizon, up, over and back down to the opposite horizon draws a semicircle, and so is split into 180 degrees, half of the full 360 degrees that make up a circle. In order to make more precise measurements, each degree is further split into 60 segments called arc minutes, with each arc minute being subdivided again into another 60 segments known as arc seconds. As a point of reference, our moon takes up 0.52 degrees of arc, or 31.2 arc minutes. The sun also takes up 0.52 degrees of arc, despite being far larger than the moon. This is because, while the sun is around 400 times larger than the moon, by a cosmic coincidence it is also around 400 times farther away. This fluke of astronomy is actually what makes eclipses possible, allowing the disk of the moon to nearly perfectly cover the disk of the sun when they line up in the sky as seen from the surface of the Earth. Anyway, back to the red star. We are going to divide up the sky above the island of Matanui using the same angular method so that we can make a like-for-like comparison of the celestial bodies in its sky. To do that, we need a full view of the celestial hemisphere above the island, which the view through the Great Telescope in the Matanui Online game handily provides. Given this is a view from a telescope, you would expect that it would give a zoomed-in view that we would have to account for in our calculations. However, if you compare the views of the sky seen both with the telescope and without it, you can see that it is actually not something we will have to worry about. While this is a view through a telescope in story, the actual view it gives you shows you the stars as being the same size and distance from each other as from this other view at the end of the game, meaning that the telescope view is not actually zoomed in at all. This makes sense from a game maker's perspective. Why create a star field with two different sizes for use in different parts of the game when you can just use the same image and add a foreground graphic for the telescope view? This time-saving measure made back in 2001 works in our favour now, as it means that we don't have to take the zoom of the telescope into account when making our measurements of the sky. When moving the telescope straight up from the horizon line, the game stops you when you are looking directly overhead, with you having to rotate the telescope if you want to continue down to the opposite horizon. This movement from the horizon to directly overhead represents 90 degrees in our measurement of the sky, as backed up by this graphic from the bottom left of the telescope view. Using this knowledge, I was able to stitch together screenshots of the telescope view as it moved, creating this composite image that shows the full 90 degrees of arc. Then, by counting the number of pixels in the image from the horizon line to the point directly overhead, I could find what fraction of a degree each pixel represented. If this image represents 90 degrees, and each degree has 60 arc minutes, which in turn has 60 arc seconds, then the full 90 degrees is equivalent to 324,000 arc seconds. The number of pixels that make up that 324,000 arcseconds was 1,433, meaning that every pixel represents around 226.1 arcseconds. Now that we have that, we can measure how many pixels the red star takes up and then do the conversion. Counting them up, the red star's diameter is 23 pixels within this image, which equates to 5,200.28 arcseconds, or 1.44 degrees. Remember how before I said that the moon only took up 0.52 degrees in the sky? This means that the red star would actually appear 2.78 times larger in the sky than the moon does. Or does it? If we look at the more detailed shots of the red star from later in the game, we can see that there is a large glow around the star, with the object itself being a smaller circle within it. Given that the star also appears to have a tail like a comet would have, perhaps this glow and tail represents outgassing of some sort from the star that has been illuminated by its light, maybe as a result of manoeuvring thrusters to maintain its position. In any case, overlaying this view with our previous measure reduces the actual star down to 8 pixels in diameter, which equates to only 1,808.79 arcseconds, or 0.5 degrees. This puts the star itself as appearing slightly smaller than our moon in the sky, although the extent of its glow makes it appear far larger. How does this compare with the apparent sizes of the other celestial bodies that can be seen in the skies of Aqua Magna, the twin suns of Solis A and B? Remember, we already calculated their apparent sizes in the sky as part of a 3-video series on Solis Magna. If you haven't checked out that mini-series, I recommend it after this video, especially if you are interested in exploring the celestial mechanics of a binary star system. In the 3rd video of that series, we calculated that the larger of the two stars, Solis A, would take up 0.95 degrees in the skies of the Solis Magna system, with the smaller Solis B taking up around 0.06 degrees, meaning that the comparison to the red star would look like this. That puts Solis A at a larger apparent size than the actual body of the red star, though it doesn't quite match the size of the glow we calculated. That being said, its nature as a true star means its brighter light would drown out any of the wider glow from the red star if they were ever in the sky at the same time. Now, what we have calculated so far covers how large the red star would appear objectively. However, this may differ from what is seen subjectively by a viewer from the surface of Aqua Magna. Have you ever noticed, looking at the sky from here on Earth, that the moon always seems far larger when it is close to the horizon when compared to how it appears when high in the sky? This is known as the moon illusion, and the reasons for it have remained elusive to scientists for centuries. Measurements of the size of the moon in the sky confirm that it is actually the same angular size no matter where in the sky it is seen, and these measurements are easy enough for you to be able to confirm for yourself. If you hold up a coin large enough to cover the moon in your field of vision when held at arm's length, you will see that it will cover the moon whether it is high in the sky or low to the horizon, despite the moon appearing to be far larger to you in the latter. The exact reason why our brains interpret the view of the moon as being larger close to the horizon is still up for debate. One possible reason is related to the way our brains perceive size by comparing objects to each other. The thinking goes that your brain is looking at objects you see on the horizon, such as trees and buildings, and is comparing the size of the moon to them, tricking you into thinking that it is closer and bigger than it really is. When the moon is high in the sky, there are no close-by objects to compare it to, so the illusion goes away. That being said, astronauts in orbit still report seeing the illusion, even though they have no objects in the foreground of their view to act as size comparisons. So the true reason for the illusion is still up for debate. What this means for the red star is that if it rises and sets like the moon does in the skies of Aqua Magna, then it may gain a similar illusory size enhancement when close to the horizon. The question is, does it rise and set like we would expect? In the view from the Great Telescope, it certainly never appears to, always being about 54 degrees above the horizon line. But then, given the game had no reason to show it rising or setting, I think we need more evidence to say whether it does or not definitively, alongside an explanation of why not if it doesn't move like that. There's one other piece of trivia from Bionicle canon that I think can help with this. When Greg was asked what the teleportation range of the red star was for its function of reviving dead beings from the Matoran universe, he stated that it was 22,300 miles, or around 35,888 kilometers when converting to metric. There is something special about this number, as it is roughly the distance at which geostationary satellites are positioned around the Earth, which sit at 35,786 kilometers or 22,236 miles. This orbit is significant as it allows satellites to appear fixed in one position in the sky to observers on the ground. What this says to me is that Greg intended for the red star to have a stationary orbit around Aqua Magna, and so quickly googled the distance at which that orbit occurred when giving his answer about the teleportation range. If the star is indeed in a stationary orbit as this evidence suggests, that would mean to the Matoran of the islands of Matanui and Voyanui, it would always be at the same height in the sky, never rising or setting, and never being close enough to the horizon line to be subject to the moon illusion. As an additional point of interest on this, the events of the online serial Riddle of the Great Beings showed that the Agori Tarduk had never seen any kind of red star. Given that we know it had been in orbit of Aqua Magna for the past 1,000 years at this point in the story, and that Aqua Magna was visible in the sky to Tarduk, given that it was one of the moons of his planet, this would suggest that whatever kind of orbit it was in kept it hidden from view. In a previous video on this channel, we discussed how Aqua Magna being tidally locked to Bara Magna could explain how the Matoran never saw that larger planet in the sky while they were on the surface of Aqua Magna, as that tidal locking would have kept Matanui and Voyanui always facing away from Bara Magna. If the red star were in a stationary orbit above those islands, like I'm suggesting here, then this would mean it would also always be hidden from view, explaining why Tarduk had never seen it before. Well, there you have it. I hope this video has been interesting and has succeeded in helping you visualize just how the red star would look if you were to see it in the sky yourself. What aspect of Bionicle lore do you want to see covered next? Let me know in the comments, and I will see you all again soon for another Bionicle Science investigation here at the Knowledge Tower.